Hi friends, today we are going to discuss about the solid principles, and I'll try to explain as much detail as possible, and also I'll try to relate with real time development scenarios which we usually face. And yeah, let's dive into the topic. Let us go with an example first. Let us take an example of a bird class where we have weight, color, okay, size, beak type, and in this we have a method called fly. Okay, so now let us go with the first principle, single responsibility principle. Single responsibility principle states that whenever we are developing a functionality, we should basically uh, associate that functionality to that specific class instead of uh, writing the conditions or keeping more conditions in the same class. For example, in this scenario, if you look at bird, okay, imagine if we have fly method. Imagine if you have fly method, and within the fly method, we need to basically check if so within the for the fly method, let us say we are passing a bird b. If b is parrot, then perform actions related to the parrot. Else if b is penguin, perform actions related to penguin. Else if b is sparrow, perform actions related to the sparrow. So if you see here, we are basically we are basically handling these bird types as in a separate scenario, and we are increasing more and more if conditions. Okay, so within the same class we are trying to address different types or the different behaviors at the same time. So do you think this is an ideal scenario? No, right? So basically when you are trying to increase more if else conditions, it is eventually it becomes like an if else hell. So the code kind of expands over the period of time in that same method, and it's not easily and also this is also not testable. If it's, let us say, imagine tomorrow if one of the developers changes a code in here, then he need to test all the scenarios, because let us say if he has changed some variable here, this variable may be this variable may be divided across all these methods, right? So this variable also could be shared across these methods, so we need to test the complete behavior. And moreover, let us say he is modifying the value as some, let us say some developer 1, he's putting some value as 10 for the same file, and developer 2 also modifying the same file with some other value, then it will result in the merge conflict. So the testability testing this kind of scenario is also a big problem, and at the same time, whenever the two developer merges the same file, when it tries to merge, you will get the merge conflicts. So this is also one of the biggest problem. So this is basically leads to maintainability of the code. So it's not maintainable, right? And also you cannot develop the code parallelly, because all is being developed within the same file, right? Yeah. So that is basically a single responsibility principle. Now let us go to open close principle. So open close principle also shares the same behavior. I mean, solid principles are interconnected to one another. So if you are aware of the first principle, that is basically connected to the second principle down the line, so and so on. So now coming to open close principle. Okay, open close principle states that open for extension and closed for modification. If you see this code, see this code, tomorrow some other person with a different name, called, let us say, he can come with some more if condition and he can add one more bird, so within the same file. So is it extendable? This file is not basically extendable, right? Because he is modifying the same file again and again, and this file is not closed. So this is violating the open close principle. Open close principle means this file should not be touched. Instead, you need to extend the behavior for the same type. For example, if you see this bird class, okay, instead of developing within the same class, you can basically extend parrot, penguin and sparrow. You can basically extend parrot, penguin and sparrow. So this is the abstract class, and you are implementing the fly method here. Okay, so tomorrow if somebody wants to extend one more type, then he can easily extend from this same class itself. Okay, so as a result, it enables the developer to test his code independently and develop his own feature independently, instead of everybody depending upon the same feature. So this is the flexibility which is providing by this open close principle. I hope you got it. Okay, so now let's go to the very important principle called Lisco substitution principle. So this is very important. Okay, so Lisco substitution principle. Be replaced instead of manipulating. So it should be easily replaceable. So that's the main concept of Lisco substitution principle. So here if you see the problem, if you from the previous open close principle, we see that we have implemented fly methods for different birds. Okay, and if you see for the penguin, penguin basically cannot fly, so it is basically swimmable. It has a swimmable feature. So but in this case you are forcing the penguin to implement the bird the fly behavior. So as a result this open close principle is basically failing here. Imagine if there is a method Imagine if there is a method to release all the birds. Okay, imagine if you are accessing b.fly. Okay, so here in this method, basically, since you are implementing the fly method for the penguin, which is not the penguin behavior, basically you will here basically either you can say throw not implemented exception, or you can return null, or you can return some default behavior. You can return some default behavior here. Okay, in either of these three cases, when you are accessing b.fly, the functionality breaks here, right? So the functionality breaks here because what you are expecting, whatever you are trying to send the behavior is not expected here. So what you want the behavior as a base needs to be implemented in the child at any cost, like. But in this case, you are saying like I cannot handle this because when you are accessing b.fly on the runtime, it obviously fails, right? So that's not a proper way to handle, right? So how can we alter this? So how can we alter this? In order to alter this, what we can do is we can put an if condition. If b is an instance of penguin, if b is not an instance of penguin, only then you perform this method. So basically you are putting a if check to make sure that condition is skipped. But is it recommended? No, because Lisco substitution principle doesn't recommend that. Okay, objects should be replaceable to the parent class without altering the correctness of the program. If you are altering or doing some patchwork here, then that is not a valid scenario for Lisco substitution principle, because you need to substitute to the parent, right? So that's the issue here. So now, so this is the case. So to overcome this scenario, what we are doing is, to overcome this scenario, basically what we do now is, from the bird we implement a flyable these are abstract classes. Okay, and one more is swimmable. So for flyable you implement the fly method, and for swimmable you extend the swim. So from flyable you'll extend parrot and sparrow, and from swimmable you'll extend the penguin, which is nothing but swim, nothing but fly here. Okay, so now we have solved the problem using a separate abstract classes, and we are extending that, and this extend from here, right? So this is how we solve the problem.